what we're going to do is we're going to get started here. I'm going to introduce myself. My name is Laura Horstman. I'm one of the 6 engineers here at the Allan Block office in Minnesota. So if you have any questions, if you can't get a hold of me, we do have a full office here that are available to your assistance, and as a resource. All right, so here we go. I'm going to open up the Allan Block AB Walls design software. It's this little icon down here below. If you do not have our software, you can always request it via email or phone conversation when you send in your evaluation form, or just follow up with that email that gets sent out. All right, so once you've clicked the software, the first thing that will come up is it will be an update page if you need to update. We have pushed a couple of updates recently. We've done a few print options and details for you. So if you do get that update visual, please update. Otherwise, it won't reinstall or update until the next update we push. So if you aren't on the current version and you don't get that update, do not hesitate to give us a call or email us, and we will get you the latest version. So the first thing that will pop up is this disclaimer page, which will show you what version you should be on, or what version you're currently on. Our most recent update is version 15.1.8. So if you ever open up your software and you're not on that version and you would like to be, you can always email us and we'll send you a new download link. All right. So on this page you can read the information of our software. I'm going to hit accept, and that's going to move us into the software itself. The first page that's going to come up is our producer information page. This is the page where you can or your local production area to make sure you get the correct block information. So the first thing, we have multiple producers across the world. We had somebody in New Zealand. So we have our Oceania producers for New Zealand and Australia. We have our Canadian producers for our Canada. So if you know your location, you can certainly ask here, or you can ask us for your local sales rep. But I'm going to just pick one of our United States ones just because I have fun with them. So I'm going to choose Adams Oldcastle, one of our producing partners in Tennessee. If you design all over the country and you don't know what producer to select, you can always give us a call and we can let you know which one would be your user. Otherwise, you can always check on their names and find their local production plant, and that'll give you a good idea of where they're going to cover. All right, so once you've picked your producer, you'll hit the next button, and this is what's going to take you to the block information page, where you're going to actually select the block and grid combo, so that way you're getting the correct test data, connection information, and all of that that's built into the software. So you're just going to choose your options. Within Allan Block, we have 4 separate collections: the AB collection, the Europa collection, the Fieldstone, and the Aztec. Not all producers have all 4 collections, so that's also another question to ask of your local sales rep or us, and we can get you in contact with them. For today's purposes, I'm going to use the AB collection, AB Classic, as that is the most widely produced and economical block that we have out there. If your clients are looking for something of a more aesthetic, we do have a blend within this collection. Also, for our Europa is the tumbled look, so it's more that old world look. For our Aztec, it's that smooth-faced look. So it's a new product out there for that more modern look. And Fieldstone is our 2-piece unit. So you got a face and an anchor unit, which you can choose between. So again, there's a lot of options within the Allan Block family. For today, like I said, I'm going to use the AB Classic. And once you select your block, the block nominal dimensions show up in the bottom left corner. So this is just some more information for you if you ever need to specify a certain nominal dimension. The next, once you've picked your block, you're then going to select your geogrid. So over here on the right, we have a list of all of the geogrids we have testing for with combination of our block. For today's purposes, I'm going to use the Strata Grid 200. Between that and MirrorGrid 3XT, those are the 2 lowest strength commercial grade grids out there. They're used for a good 80 to 90% of the jobs out there. They're a good, strong one to start with. And if you ever decide halfway through your design that you need a stronger grid, we do have options that the software will automatically choose the next 2 strongest. So that way, when you go through the system, if you need to change your stronger grid, we have it available for you while you're in there instead of having to come back. All right, so once you've picked your block and grid, you hit the next button, and it will take you to the project information page. This is where you're going to put in as much or as little information as you want to appear on any of our outputs. So I'm just going to throw something in here so that way we have something to look at on our outputs. All right, so once I've completed that, I'm going to hit the next button, and it's going to take us to our beginning or home screen. So in our software, we have two ways to move through it. You can use the Design tab across the top, which will allow you to step between all of the different pages as you go, or you can use the big blue arrows in the bottom left or right-hand corners. This will move you from one page to the next in a sequential order. So before we kick off into much more of our design, what I'm going to hopefully take you through in the next 45 minutes or so is an elevation screen, plan view, panel screen, and cross-sections, along with a full material estimate and all of our print outputs and other outputs that we have. So hopefully I cover everything that you need and you get a good understanding of what our software is. All right. So I'm going to start off with hitting the big blue arrow to the right. It's going to take me to our elevation page. This is a pretty straightforward page, pretty easy and simple to do. What I'm going to do is I'm going to use the callouts of our example file and just plug in our top and bottom of walls so we can get a start of an elevation view for our wall. So to start off with, I'm going to fill in my top of wall of 93.5 based off of our callout over here on the left. And for our grade value, what our software terms as grade is the finished grade below the wall. So usually that shows up on plan sets as a bottom of wall elevation, because most of the time whoever's drawing your plans may not consider how much needs to be buried. They're just worried about the final look. So what we're going to do is we're going to assume for most of the time any bottom of wall callout is actually our grade value. So I'm going to say 93. And while I'm in this grade cell box, I'm going to hit the Enter button, which will automatically calculate my bottom of wall based off of our minimum buried block cell in the bottom left-hand corner. Now that is just a default of our system at 1 foot. You can always change it to whatever you need based off of your design. The rule of thumb for the industry is for every foot of wall height, you're going to bury 1 inch of block. And for our Canada people, for our metrics, it's 25 millimeters per foot is about a foot, so you're looking at 88 millimeters per meter is what you're going to put in. So that's just the standard. If you have a tall wall, you're going to follow those rules, but if you have a slope below the wall, you may have to adjust for what we term a 5-foot benchmark from the toe of wall to the crest of slope. If you have any questions on that, we can certainly provide you a schematic of what we're talking about on that. Sometimes people have a different terminology. All right, so we have our top of wall, our grade, and our bottom of wall. Now I'm going to fill in my station of the lineal length of our wall at this point is 0 feet, so I'm going to fill in a 0. Then I'm going to use my tab button to the next point, and I'm going to fill that in. And I'm going to look at station 13, where my top of wall hasn't changed, but my grade value has, based on the contours. Now when I hit the tab and fill in the station and hit Enter at station 13, it's going to now draw my wall based on those 2 points in the visual screen above. Now, what we're looking at is just the representation of how the wall will look. As we fill in more points, that's going to fill in more. And I did not mention this for those people who work in metric. On the home page, I'm going to hit the big blue arrow to the left and go back to the home page. This is the only page where you can transition from system units. So currently I was in feet on that elevation page, but you can always change your system units to SI if you need to go into metric. We do have that option, but only on the home page. So I'm going to stay in feet for this. And then I'm going to go back to my elevation page, and we're going to just fill in the rest of these stations. While I'm filling that in, if you guys have any questions, since it is a pretty easy and straightforward on how to do this, just go ahead and use that chat box, and we'll see if we can answer them. All right. right, so at this point, my visual has kind of gone off the page. If you ever want to see the full visual and it has gone off the page, all you have to do is either use the zoom buttons on the Adobe screen, use the scroll bar across the bottom, or use what we term a zoom extends button or a coordinate system down here in the bottom left-hand corner. And that's going to resize the image for every point now that I put in. It's going to resize that so we can see the entire wall. Got a couple points left to go. And my last point. And 287. All right. Pretty easy and straightforward. All right. Can you show where you're getting the numbers for the stations? All right. So just move my box out of the way. Whoops. How about I just minimize that out? So I was using station 88 with my call-out boxes, reading the contour lines to see which my values are going to be on station 220 and station 13, then the last one. If you ever want to recreate this example file, we do have it as an option to be downloaded within the software. So if you ever have a question on that, we can always show you that. All right. And if you need any assistance with reading plans, you can always give us a call too. We also have that as well. All right. So off of the elevation page, if we're done here, since it is pretty easy and straightforward, I'm going to hit the big blue arrow to the right, and it'll go on to the plan view page. Now, I'm still going to reference that example file, but in this one, I have created my coordinate system, which is what I'm going to put in here. This is a similar setup where we have our spreadsheet below and our view box above. We will have our coordinate system, our x and y values that we drew on the plans ourselves, and we did that to scale. So what I'm going to do is I'm going to read off my points, starting with station 0, 0, with an x of 0 and a y of 62. If I can type. And then if we follow the rest of our points, I'm just going to go straight to the next corner, which is at station 88, and a value of 9. By now I have 2 points. When I hit enter, it's going to draw my wall on here. And if you notice, I only typed in 2 points, but in the visual I have 3 points. The reason I have 3 points is it's copying from station elevation point from our elevation page and ghosting it in here as well. So you can see it. So that way it references you have put a point in, does it match what it's supposed to look like on your plans? And looking at this line segment to this line segment, it looks accurate. So we know we're good. All right, so I'm going to fill in the rest of my points. To view the example file, I'll move this out of the way after I filled in all the points, just for those who want to see it. And I'm going to throw in my last one. Ooh, that is not right. It is. Something has happened. Let me clear my plan and redo it, because apparently something has happened. Yes. All right, let's start again. Station 0 and 62. 70 and 9. Well, 70 and 9. I'm just using my tab button to move through all of these screens. 98 and 0. 265 and 24. That looks better. That looks like our plan set, doesn't it? Now again, it's gone off the page, so I'm using the scroll bar across the bottom, or we do have another zoom extends button down here. So now that looks like our plan set. I'm going to show you the example file again, just as a reference. And then we'll bring that right back up. So on this plan view, this is just using a Cartesian coordinate system. However, if you already have a plan set created, you can import a polyline from an existing plan set. I can show you how to do that in a different tutorial. Right now I'm just going to show you the example, the coordinate system. But a few more talking points on this page before I leave. The plan view isn't essential to the full-out design. So if you want to skip this, you can, but we do recommend you do it because it does allow you to have a good visual, and also it allows you to double-check your measurements. By doing a Cartesian coordinate system and by measuring to scale, it shows you how close your measuring is, and so it allows you to do a nice check on that to see if there's something wrong. And it also allows you to modify your plan view because as an industry, we don't really like to see mitered corners just because now the contractor has to cut all of those blocks, and now you're going to have a seam right at that corner, and as these walls are meant to flex, that seam might open and close depending on the movement, so it might also create an eyesore. So what we would prefer to see are curves or a radius or radii. So we have a couple of ways in our software to do that. You can put a radius at a station. So let's say if I want to put a radius at station 1, I can do that. Or I can do a radius on a line segment. So I'm going to show you both ways as reference, and I'm going to start with a radius at a station. So I'm going to hit the Add Radius button after I fill in a radius value. I'm going to hit 20 feet for a radius. I'm just assuming a number here. And hit Add Radius. It's going to ask me what station I want to put it at, and that's based off of the points that you put in here. So I'm going to say station number 1 because that is our corner. So I'm going to hit OK. And it has now added a radius at my corner. Now, granted, it's in the wrong direction. Sometimes that happens, but there's an easy way to fix that. Underneath the point 1A, they have these reverse concavity buttons. So I'm going to select one. It's going to reverse the concavity of that radius, and I can now see that it's in the right direction for our lines. Now, once you've put in a radius and you decide you don't like it, we would strongly suggest undoing it right away. And to do that, you'd hit the undo button in the bottom left-hand corner. Our undo button only works for the last radius input, not for continuous undos. So I'm going to remove that. And now I'm back to my original plan set. So I can show you the second radius option we have, and that's doing it on a line segment. To do that, you will use the radius cell line of the spreadsheet below, and you're going to put in the radius value at the starting point of the line segment you're going to change. I'm going to change segment 1, 2, just so that way it makes a nice smooth transition from start to end. So I'm going to say under line point 1, we're going to put in a radius of 20 feet, just making another number up there. And when I hit enter, it's now going to change that line segment into a radius. Now, as we look here, it's not the smoothest of transitions from one to the other, so I can change my radius value just by changing the number in the spreadsheet. I know 40 works, so when I hit enter again, we now have a better looking line. All right, pretty straightforward, pretty easy to use. If you have any questions or you can't remember if I show you something and you want to do it again and implement it on your own projects, we do have training videos, or you can always call us and we can always talk to you through it again. All right, so that was the plan view. I'm now going to move on to the next view by hitting the big blue arrow in the bottom right corner and taking me to my panel view. Now, this is probably the hardest one to describe, so if you have questions, please ask them, or we can certainly address them afterwards. So bear with me here. What we're looking at is we're looking at the black outline of our wall for the first time based off of our elevation view and our block increments. So that's why it's very important to have the correct producer and the block, so that way they do vary from producer to producer. All right. So on this page, what we're going to do, or at least our actions for this page, is we're going to cut our wall into panels, and then we're going to take one cross-section for that panel. So what we're going to do is we're going to decide our panel cuts based off of geogrid roll widths, and that's what these green lines are representing. They are representing the end of a geogrid roll, so it's a constructability standpoint for our contractors. So if you have to change grid depths at a certain point in the wall, we're doing it at the end of a grid. Less waste on the site and less cutting for them to have to do. All right. So there's a couple of ways or decision options to use on how to cut your wall into panels. You can either go based on above wall conditions, so you have a slope on one section, you have a surcharge on another, or you have absolutely nothing above your wall. You can make that decision based off of the location in your wall. So if it's at 30 feet, you would find the green line that is close to it by using the X and Y coordinate system below. You can notice here it's going in the lineal length of your wall, so you can determine that way if you want to make your cut at a certain lineal footage. Another way to do it is using the blue lines. Those are representing points from your plan view, so that way if you have a corner, a start and end of a curve, you can always select those as well if you have to make a transition there, because they're already going to be cutting in those locations anyway. What I'm going to show you is how I would cut it based off of elevation of the wall. So in our office, we like to stay around 3 elevation changes, and that's so if you cut and design your wall, you're not going overly conservative. So what I mean by that is I'm going to select this second green line from the left, and if I look at the bottom of wall, I have 3 step downs of our bottom of wall. So that's by my 3 elevation changes. So that way I can take a conservative approach and design for the tallest point of that section. That's going to represent the whole panel. All right, so based on that, I'm going to cut or panel the rest of my wall out. And if you have any questions while I'm doing that, feel free to ask. I'm sure Jeremy and Logan, who are fellow colleagues of mine, would be happy to answer if you do have any. 2, 3, sorry, I can cut here. There. No questions. I'm just going to finish doing this out. All right. Last one. All right. So once you've paneled out your wall, and again, if that was confusing for you and you have your own project you want to do, feel free to give us a call. Once you're done paneling out your wall and you're happy with how you've chosen it, you can hit the Finish Finding Panels button or the big blue arrow to the right. It does the same thing, and it's going to take us to the next page, which is our panel summary page. It's pretty much going to there's no actions to happen on this page. It's just telling you what you've just done on the previous section. So it's showing us our wall with the darker green as our buried values, and the purplish blue rectangles behind are showing us what chunk of our wall is that panel. And then the arrows are telling you where on that panel are we taking our cross section. So there's nothing really to happen on this page. It's just a look and summary. Another good thing about this page is the more blue you see, the more conservative your design. So if you see a lot of blue and you're like, maybe you want to cut it down, you can always come back in, hit the redefine sections, and going back to the previous page and adding another panel cut. It's as easy as that. All right. So with no questions that I can see, we're going to now move out of the geometry portion of our software and into the actual engineering designing portion. All right. So once we're in this page, the first thing that pops up is our soil information page. This is where you're going to put in your soil friction angle and unit weights of your soil that you usually get from a geotech report, or if you are a geotech yourself, you know your area and you know the soils, you can put that value in yourself. By no means is 30 degrees and 120 unit weights a conservative number. It's more of a relatively common value that we've seen out there. You can change it, you can use it, but if you are going to use it, like we're going to today, we're going to use the defaults. When you hit Apply to All Sections, it's going to ask to double check, do you want to use the defaults, just as another confirming that that is what your site has. I'm going to say yes for this case. And then we're going to use those degrees of information for our design. Now, since some of you may have a seismic coefficient, I am going to show you, or a seismic option that you have to design for. There is a seismic parameters tab across the top here where you can put in your seismic horizontal peak ground acceleration value. If you don't know what the value, since there's a lot of seismic coefficients out there, if you don't know which exact value you're going to use on this page, you can always contact us. We do have options and resources to find that for you or assist you with that. Today I'm not going to apply it, but it's as easy as typing in a value and hitting apply to all sections. Or if you just want to apply it to one section, you just have to put it in and hit hide. It's going to apply it just to your section that you're on. I'm not going to use seismic today, so I'm just going to use my soils. And I'm going to hit the hide button, and it's going to make this go away. Now, if you've accidentally hit the hide button and you need to rechange your soils or add a seismic parameter, to view that screen again, you just hit the Design Parameters button between the two arrows, and it will bring it up. And then you can just hide it again. All right. So there's a lot of information on this screen, and I'm going to walk you through it. We try and break it up as simple as possible. Everything on the left is all of your decision options. Everything on the right is all of your variables and results, your safety factors, everything that you use for the calculations. Now, the spreadsheet below, when that's filled in, is a kind of combination of both. It's going to show you the safety factors for the internal calculations, but you can also make changes to your grids in that location. All right, to start us off, I'll just take us a tour down the left-hand side for all of our action areas, so that way we know what we're going to do. Starting off in the top left, we have a section geometry section number of section 6. This is telling us, based off of the heights of our wall, the software has determined that section 6 is our tallest section, so we're going to use that as a starting point and move from there. So that way we hopefully have less modifications to make on the smaller sections. Below that, we have section height, which gives you the block height, how many courses you have, and the total setback of the block. This isn't anything that you can change on this page, but if you do need to change your height of your wall, you have to go back to the elevation page. All right. Now, for the buried block, this is a little different. This one is a set number based off of your buried block value on the elevation page. However, this is telling us it's in courses, not by feet or meters. It's telling you it's going to bury 1.4 courses. All right, just making sure I had that clarification out there. Now, below this, we have our geogrid information. This is actually where you're going to start doing all of your decision making. Based off of the new industry push for zero wall failures, we have an initiative out there for best practices, which is a document based off of testing and industry experience for the past 30 so years. And based on best practices, it has been determined that use grid when you can. It's a relatively inexpensive insurance to a wall design. It's easy to add. In the scheme of things, it's not that much of an added cost. But with that being said, we do have that option to do a gravity wall without geogrid, depending on site constraints or whatnot. You do have that option. Below that, also based on best practices, our course spacing is set to 2 courses. So you have 2 courses of block between each layer of grid. That's based off of a full seismic testing that we had done in the early 2000s. So if you ever want to see that, we do have that option. We can share you that testing as well. You can go 3 course spacing if you so choose, but we do recommend sticking with the 2 course spacing per best practices. Below that, we do have the minimum grid length per wall height set at 60. That is an industry minimum. It has nothing to do with Allan Block. It is an industry minimum. You can, however, go 70% or greater, depending on your design style. I do believe there is some codes out there that require 70% the wall height, so we do have that option as well. Below that, last thing in our grid area is we have our minimum grid length used for external stability calculations. And that is either the minimum length that the grid can ever be it 4 feet, 3 feet, or it's your 60% height value. So you can always, it will show you the minimum grid used in the calculation. All right, so at this point, I'm going to hit the calculate button, which is going to give me a flat top, no surcharge, standard wall design. When I hit that calculate button, it has applied the first layer of grid on the first course of block, also per best practices, and then it has run the external calculations, and all of our variables are viewed in the wall results box here on the left. It also gives you, towards the bottom of that box, bearing information. So if you ever have to worry about bearing, you have your values here. Our externals are viewed below with our industry minimums and our actual values in the calculations. In the spreadsheet below, we have all of our internal calculations, providing you all of your overstress, block pullout, and soil pullout safety factors. So and then this is also the area where you have to make any changes if you need to. At this point, everything is above the minimum because nothing has yelled at us, and all of our cells are white with black text. If something were to fail, the corresponding cell to the corresponding safety factor would turn yellow and the text would turn red. So it would make it blatantly easy for you to find if something were to fail and you can fix it. All right. Next thing I'm going to cover is our surcharges. We have two ways to apply a surcharge. So let's assume for this cross-section that this wall is going to hold up a sidewalk and a roadway at the same time. So what I'm going to do is I'm going to apply my roadway surcharge as a surcharge, or a continuous one, and I'm going to say it's 250 PSF. Once I've put in a value, it has calculated my distance from toe as to be the setback of the block plus the block depth, so my surcharge is going to start right behind the cap. So when I hit calculate again, it's going to now apply that surcharge right behind the cap. Now, since I said this was also going to hold up a sidewalk between the wall and the roadway, I'm going to now apply a line load value of 100 PSF with a starting location of 1.65 right behind the cap. And I'm going to say that this sidewalk is 4 feet deep. So I'm going to say my sidewalk ends at 5.65 by just adding 4 feet to the original point. Now, I'm going to move my roadway surcharge to after the sidewalk because most of the time they don't happen at the same time. So I'm going to say that this is 5.65 and hit recalculate. And it's going to re-visualize my cross-section with my surcharge line load, and it ran all of the internal calculations again. All right. So pretty straightforward and easy to do. With our surcharges, we do have the option for both live and dead. So you have those options as well. To move on to the slopes, I'm going to zero these all back out to our standard flat top wall. And I'm now going to apply a slope by using the area in the bottom left-hand corner. You can either go by degree of slope, or you can go by rise and run, whichever one you know. So I'm going to do a 3-to-1 slope. And when I hit calculate now, it's going to apply a 3-to-1 slope above my wall at 50 feet in height. And that is just a reference for us just to assume that it's going on for a continuous slope beyond the wall, or at least the wall influence. Now, if you know your slope only goes up a certain height, so let's say 1 foot, sometimes that is the case, and I hit calculate, it's now going to redraw and reanalyze this cross-section as a broken back slope. So you have a slope and then a flat top wall. And so then at this point, you have the option to add in your surcharges if you have that above your wall as well. So you have a multiple combination of adding a slope and surcharges to be as close to as-built conditions as you can get. All right, so at this point, I'm going to assume that this is the geometry of my wall. I got that slight slope, I got that surcharge above, and I'm going to hit the Calculate Internal Compound Stability button. This is going to run a modified Bishop's analysis similar to a global analysis, except it's going to stay within the wall envelope instead of beyond. So it does not replace a global analysis. And that's what this pop-up is telling you. Our software is also available to export a section to RESA, which is a Global Stability Program, RESSA, which will allow you to run a global analysis without having to plug in all of your geometry points. That's just what this pop-up is telling you. So if I hit OK, it's going to ask if I want to put grids into the slope since I do have a slope. I do not want to reinforce the slope, so I'm going to say no. And then it's going to provide me with all of the parameters it used for those internal compound stability calculations, or ICS. So as you can see, it stays within the wall envelope, doesn't go below the blocks, and it doesn't go beyond 2H. So it does not replace a global. Looking at this, it also tells me it did over 34,000 iterations to find the worst case slip arc for each course of block. So if I hit hide, it's going to display those worst case slip arcs on my cross section, so that way if they were to fail, we can see what it looks like. And then since they are all green and the safety factors over on the right are above the minimum, it is a safe design. Now, I don't know if you guys noticed, but there's this construction detail that showed up. It's just going to give a quick snapshot of what the elevation would look like as a final. It's a good thing to look at to see what wall you're doing if you have to make any changes. I'm not going to view it, so I'm going to close them out. And if I don't want them to pop up again, I'm going to just turn off this yes construction elevation button, and I'm going to just turn it to no, so I don't have to see that again. All right, so we've run slope, surcharge, we've run our internal calculations, all of our safety factors are above the minimum, so we have a good design. I'm going to move on to the next section. To do that, I'm going to use the little blue arrows next to our section 6, going in either direction because I am going to have to cover them all at some point. And now, in this instead of using calculate, I'm going to hit the match grids left button, which is going to keep the grids on the same coursing from section to section. And if you ever are curious if you've hit the match grids versus calculate, you can always just go and view them again by hitting the big blue arrow to the left. It'll take you back to the panel summary page, but as you scroll through, you'll see the areas where you actually have grid involved. Now, if they jump section, you would notice because the grids will no longer line up when they cross from one panel to the other. All right, big blue arrow to the right. So back into our section area, we've calculated 2 of 8. Now, if I want to leave this section, I can. But now, since I did not run internal compound stability, it's asking if I want to. You don't have to do it on every section, but we do like to see it because it gives you a more complete idea of what the soil is doing within that solid mass. Right now, I'm going to say no, just for expedience sake, so we can see all of them. I'm going to hit don't show this again. And now we're moved on to section 8. At this point, I'm going to hit the match grids left again, and it's going to provide me with my cross-section image. Now, if you have noticed, when I hit that match grids, it's keeping the same slope and surcharge values as my first section. So it's pretty fast and straightforward. As soon as you've done one section and your top of wall conditions don't change, all you have to do is hit rinse and repeat like I've been doing. Match grids, calculate internal, and then you are complete and ready to go on to the next section. All right, so I've got 3 of 8 done. I'm going to use the little blue arrows to go down to the next sections. Section 5, I'm going to hit match grids right now because I'm on the other side of my starting section. And now if you notice, the first layer of grid starts on the second course of block. That is acceptable based on 2 course spacing and with best practices, so this is a good design. All right, new calculate internal compound stability. Now, I got this pop-up saying more than 50% of the slip arcs at the back of the wall envelope. This is telling me that of the analyzed slip arcs, they are good, but the worst case may be beyond the wall envelope. So it's just letting you know you may want to consider a global analysis. It's all up to your discretion since you are the engineer of record if global analysis is a concern on the site. At this point, I'm just going to say OK, because it's just telling me to think about it. It's not making me do anything. We ran over 26,000 iterations, hit hide, and everything is still good and above my minimums. I'm not going to be concerned on it right now, just because for expedience sakes, but that is a choice that you have to decide if global is an issue. All right, so section 4 of 8. So let's go down to section 4. Match grids right again. See, pretty standard. All right. Now, looking at this, I've got 2 course spacing at the bottom of my wall, but I have 4 courses at the top. You have the choice to leave it as is and try and analyze it as a complex composite structure, which is a totally different tutorial that we do offer. But right now, I'm going to say I'm going to add a layer of grid. And to do that, I'm going to use the spreadsheet below by hitting the Edit Spacing button above it. It's going to turn blue. And then I'm going to select the course of block that I want to add my layer of grid to. In this case, I'm going to add it to course 7. And it's going to add that layer of grid, and it ran those calculations all by adding that layer of grid. Now, based off of best practices, if you have a slope, a surcharge, or even seismic, they want to extend that top layer of grid. So what I'm going to do is I'm going to lengthen that top layer of grid by hitting the Edit Lengths button, again above the spreadsheet, and click on the course of grid I want to edit. So I'm going to hit the course 4 with a 4 foot, and I'm going to match it to the one before. That's just another constructability standpoint, less grid numbers, less chance of a contractor messing up. All right, so I'm going to hit OK. It's going to add that length of grid, reran the calculation so I don't have to hit match grids or calculate, because that would just undo everything I've done. All right, So at this point, we have a safe design. It's up to the engineer of record. You have a couple of options here. You can either leave this layer of grid at its extended length, shorten it, and those are your two options. Both are fine, and they're both up to you depending on how you want to do it. I'm just going to leave it as is, just so that way we have it here. And then I'm going to go to the next section. Section 3, match grids right. I have the same issue. And the reason I'm having this issue is because our wall is stepping up. If you remember from our panel elevation screen, the wall is just starting to step up. So I didn't have grids in the previous sections. So now I just have to add it. So in this case, since grids are starting on the first course of block, I can do a quick little trick. I can hit the calculate button instead of the match grids, because that calculate will put the grids on the first course of block no matter what. So if your grids are already there based off of the match grids, you can hit the calculate button. It'll make those adjustments for you without you having to do extra steps. But that's only if the grid starts on the first course of block. All right, a couple more sections to go, and then I'll be able to show you everything else. All right, so looking at this, we have 2-course spacing. Don't need to add any layers of grid here. External stabilities are good and above safety factor. Going to section 1, same thing, all good designs. Now, I'm going to purposefully make one of these a gravity wall that I know won't work. So I'm going to section 3, and I'm going to make this a gravity wall, just to show you what would happen if something were to fail, just so that way you don't miss anything if something were to happen. So I'm going to go over to the left here and go Design with Geogrids to No. I'm going to hit Calculate because my Match Grids buttons have disappeared. The first thing that pops up is our sections do not meet safety factor. So if by some chance you gloss over that and hit OK, you also get this big Do Not Build section across your cross section. So it's going to tell you right away, don't build it and why. Your sliding and overturning factors are below minimum. Now, this information, the cells, the color, and the text, that's going to happen for all of the corresponding cells as well in the internals. So if one of them is failing, you can find it easy and make the change necessary. All right. I'm going to change this back to our gridded wall just so that way we have everything correct. And now I'm going to move on to the next page of our software. Since I have designed 8 of 8, I am complete with my wall design. I'm going to hit the big blue arrow to the right, and it's going to take me to our elevation or our estimate or worksheet page. It's the last page of our software, and it gives you a full, complete estimate of the materials that are going to be needed for the software. All of the block, grid, soil, all of it is here for your use. The one thing we do want you to do on this page, if you want, is to hit the Send Project Information button. What it's going to do is it's going to create this email template for you to send just the project information along with the quantities to our local sales rep, so that way if this project is coming his way, he can get an estimate ready for when contractors ask, or he can supply it to any of your contractors who would like to have, who are wanting to bid on this, or provide you with other contractors out there. What it also allows you to have is this correspondence information area, so that way you can type in direct information to the local sales rep. So if you want to know if they have a specific color, the specific product, do they have the grid that you designed with, all of that information you can type right in here as a question straight to the sales rep. He can respond back to it and probably even provide you pricing if that's something you wish. Or you can just use it as a way to provide them with information. This is for such and such a contractor, or this is this project. Just another direct communication to our sales reps. All right, so that's it. I'm not going to send it right now because we are not actually building this wall. All right, so I'm going to minimize that. And then now I'm going to go into our outputs. So we have a few other outputs besides that Send Info button. And I'm going to hit the File and Print to go to our print page. And it's going to cycle through all the information, gather it all up, and provide me with a print options page. On this page, on the left-hand side, are all of the available pages to print in any of our PDFs. Everything on the right are all of our details, or typical details that you can add to any printout. If you're not sure what they look like, we do have a view button off to the left of each individual one, which will allow you to see what that detail looks like. Or if you want, you can hit the AB typical details and it'll take you to a web page which will have all of them available to you as well. So at this point, I'm going to hit Print Selected, and it's going to create me a PDF, which will display in our background, of our entire design. So if we look at this, we have our title page with our title across the top, our project information as we put in at the beginning of the software. And if you so choose, you can put in your company information, your company logo, and even your license information so you can finalize any design straight from the software. It's an option available to you. Not everybody will use it because most of you probably have your own details and submittal packages available. So as we scroll through, we had our starting page, our disclaimer, all of our specifications and notes that are available to you, which you can add or remove as you see fit. Our general notes, which are the soil information, and if you use seismic, it will display here as well. And then it will take us to a plan view, which will allow you to see the grid depths involved for your design. The elevation view with your grid layers. And then your cross-section, your design variables over onto the right. And then on the next page will be all of your internal calculations for every layer of grid. And then it will repeat for every section that you have. And if you run internal compound stability, you'll have another set of pages afterwards. So that is in reference on page section 5. We had internals, we have internal compound stability results, and geometry, so if you ever wanted to recreate that slip arc. And then it just repeats for all of our sections. After that, we get our typical details, and then the worksheet page at the end. Now all of these pages are things you can add or remove as you see fit on that printout, on that print page. Alright, so that was what we term usually our engineering review because it had all of those calculation values and variables. So I'm going to show you the next one we have is our shop drawings. So if you go on that print page and you change the paper size from 8.5 by 11 to 11 by 17, it's going to remove the calculations and just hit print. For some reason, it will display. Here we go. And it will show us the same title page as before, except now it's just in a bigger print. So on the next page we have our disclaimer, we have our specifications, and then you also have water management specifications in the 2 columns, general notes as well. And then we get our plan view just like before. But our elevation are those construction details that we turned off earlier. It gives you the block increments, step up, step downs, and your panel sections for your design. And then it will then show you, after the elevation, it will show you your cross section with its corresponding panel for every single one. And then you got your typical details and then your worksheet page again. So all of these are available to you straight from our software. No added input, all of it's right there. Alright, so for the last output, we do have one more, and it involves AutoCAD. So if you do have AutoCAD, this is great for you, or if you have your own template, I am going to get rid of that print page and bring up our software again and go to File, DXF RESA functions. This is where you can export everything that we've just designed into AutoCAD. So right over here on the left, I'm going to select everything that I want to export and export to DXF. I'm going to just tell it what I want it to be, and I'm going to find it so I can open it up shortly here. And while it's creating that, when I mentioned earlier on the plan view for the imports, that's everything on the right here as well. And when I mentioned also for RESA to export a cross-section, it's right here on the next tab over. So you can always tell it what section and export to RESA. And I do believe Logan and my colleagues have been telling you where you can get that software as well. All right, so once we've exported it, I'm going to go find that file and open up the software, open up the file itself. And then I'm going to zoom extends so everybody can see it all. Now, what you have here is you get your plan view with your grid depths and your setbacks. You get your elevation views with all of your block increments, and everything here is editable. You can change it as you see fit. We've got our grid layers, we've got our panel views, and then below that we have our cross sections, which will give you all of your design options, and then your corresponding panels and your specifications and notes. So there was no added time in here. As you were designing it in the software, it allowed you to export it as well. So you're doing it 2 tasks at once, designing and drafting all at once. All right. I think I did that in 48 minutes, a little longer than I expected, but not too bad. Were there any questions, something that I didn't cover? We have a few minutes left here. All right. Looks like I got a couple people typing to give me something. All right, so at the end of this, we have finished the tutorial. If everybody who needs continuing education credits would like to stay in the meeting, as soon as I end it, it will then allow you to, the evaluation form will show up so that way you can fill out and send it to us for those continuing education credits. All right, is there any criteria to select the sections? Adnan, is based off of either height, above wall conditions, your corners or curves. If you want some more information on that, we can do a one-on-one tutorial with you too as well to dive into more information. Do you have the ability to design to handrails or fencing above the wall? Within the software, we do not have that capability, Jerry. However, we do have MathCAD files that will allow us to calculate any fence overturning calculations that any of their fence or railings would apply to the wall based off of information from our software. So if you do design a wall in AB Walls, you can send us the file and we can run a calculation for you, or we can send you the MathCAD file yourself and walk you through that as well. How do you design walls over 10 feet? Good question, Ricky. As soon as you're done with this tutorial and you have our software, we would provide you with an engineering password, which would give you the ability to design over 10 feet. And that's kind of getting in the realm of, depending on your location, a tall wall. So you may want to consider some tall wall considerations from our best practices as well. Can the software analyze terraced walls? For our software, terraced walls are a different thing. You can only design one wall at a time. So if you were going to do a terrace wall, you'd have to apply that upper wall as a surcharge. And then once you export it, you can make your cross sections from there. But we can also cover that in a more advanced tutorial if you need that, John. Anything else? We have a few minutes left. All right. Looks like I got a couple more coming in, but thank you all for attending. If you do have questions, require our software, want that eval form, feel free to email us, contact us for this. There will be a recording of this for rewatching. Very good question. I have recorded this session, so we will put it up there available for you to use on YouTube. We'll probably send you a link to that once this is done or once we have it converted for you. And if you ever have any questions, do not hesitate to call any one of us here at the engineering department or email us at engineering@allanblock.com or abuonline@allanblock.com. Both of them will reach us as well. Jerry, I guess I'm not understanding your question, but we can certainly talk to you outside of this webinar for you. But for the profile view, we can certainly assist with you with that as well. All right. Any other questions? If not, I guess I can close this a few minutes early. Unless you have more, we can certainly keep talking. All right. Please send me the password for designing tall walls. All right, Ricky, we'll make sure we send that in with you. So if you send in your evaluation form, just say we would like the engineering password and we'll send it to you as well, Ricky. All right. So at this point, I guess I'm going to just call it good. If you have any questions that I did not answer or you need some more in-depth, do not hesitate to reach out for us. Can the software design for impact load on a wall? Are you talking like a vehicle impact on the face of the wall or as a railing? Railing. All right. So for an impact railing, we would like it to be 3 feet behind the back of the wall, just so that way any passive pressure from the soil will assist with any overturning calculations. However, if you need it closer than that, we would recommend having either a moment slab to divert any of those overturning forces away from the wall and back into your pavement. We can always assist with that in any other questions you have or any specific project ones that you have. All right, we got some good questions here. All right. I guess I'll call that early. So if you do have that evaluation form, don't forget to send it in. All right. For water features being fed into the wall or over top the wall. You do pose a good question, since water is the #1 enemy for retaining walls. That gets a little bit more in depth on more of our advanced features, and we can certainly assist you with that on a one-to-one basis there, Shan. All right. I'm going to call that good. Have a good rest of your day, guys, and thank you for attending. Have a good rest of your day.